Good evening, everyone. Buenas tardes. It's a pleasure to welcome to this bilateral event between Institution of Civil Engineers and the Spanish Council of Civil Engineers. Following the success of our summit earlier today, we now have the opportunity to explore a crucial topic, the decarbonization of infrastructures and the role of standards like PAS 2080 in helping us to reach this ambitious goal. We are especially grateful for your presence here today, both the ones here in our auditorium and the ones following us virtually connected, and we extend a warm welcome to our special guest, Sean Harris, ICE Deputy General Director and Membership Director, and Fernando Pons, Senior Trade and Investment Advisor at the British Embassy in Spain. Thank you to both of you for being here today. This event marks the third year of our bilateral meetings, a tradition that has consistently strengthened bonds between our institutions and facilitated meaningful discussion around shared priorities. Our agenda for today will proceed as follows. First, we will open the session with some remarks from our President, Miguel Ángel Carrillo. He will be joined by Sean Harris and Fernando Pons in setting the stage for the evening. After the introduction, Enrique Huertas, ICE representative in Spain, will guide us into the main element of the program. Our keynote address will be delivered by Luis Barlow and Maria Manidaki, two leading ICE experts who have been instrumental in the development and implementation of the PAS 2080 standard. They will be joined by a Spanish specialist in infrastructures decarbonization for a roundtable discussion and practical application challenges and innovation in sustainable structures, all aligned with our shared goals for a low-carbon future. Following the keynote and the roundtable, we invite you to participate in a Q&A session that will be moderated by our representative in the UK, Luis Rico. This will be a valuable chance to engage with the speakers, exchange ideas, and explore new perspectives on the challenges we face. To close the event, we welcome you to join us for a cocktail reception where you can continue this conversation and connect with colleagues and experts. Thank you for all your commitment to advancing sustainable practices within our industry. Let's make the most of this opportunity to share knowledge, learn from one another, and build connections that will support our work in the next years. Thank you once again, and I hope you will enjoy the evening. And now I invite our President, Miguel Ángel Carrillo, to take the floor.
Buenas tardes, good evening. En todos los casos hay alguna excepción y en esta el evento es en inglés, pero la excepción soy yo. Lo voy a hacer en español, la presentación mía. Bueno, es un placer hoy acoger en el Colegio de Ingenieros de Caminos, Canales y Puertos esta cumbre bilateral que lleva por título Innovación y Sostenibilidad por un futuro bajo en carbono, que organizamos desde luego con el Instituto of Civil Engineers del Reino Unido. Así que, apreciado Sean Harris, director general adjunto del ICE, es un placer, desde luego, recibirte en España. Quiero agradecer la participación en esta apertura de Fernando Pons, asesor del Departamento de Comercio Internacional de la Embajada Británica en España, y también a todos los cualificados ponentes que van a intervenir en esta jornada, entre los que se encuentran los vocales de la Junta de Gobierno, Arcadio Gil y Luis Villarroya, que los tenemos aquí a los dos. Esta sesión se enmarca en la colaboración que mantiene el Colegio y el ICE a través de un convenio que firmamos en el año 2022 en el que articulamos encuentros alternos en el Reino Unido y en España, que reafirman el compromiso compartido con nuestros asociados y colegiados. Me gustaría enviar un saludo especial a los más de 200 ingenieros de Caminos, Canales y Puertos españoles, colegiados, que desarrollan su actividad profesional en el Reino Unido, y también a los ingenieros civiles ingleses que ejercen su actividad en nuestro país. Celebramos esta sesión bajo la conmoción que todos sentimos por la pérdida a día de hoy de 224 vidas y 16 personas desaparecidas por las inundaciones que ha provocado la dana de finales de octubre en las comunidades de Andalucía, Castilla-La Mancha y la Comunidad Valenciana. Permitidme que recuerde que en el Colegio hemos activado el Plan de Ayuda y Colaboración Colegial DANA 2024, en el que a través de distintas fases planteamos un programa de medidas en el ámbito social, técnico y económico. Durante el día de ayer y hoy seguimos muy atentos a la evolución de las lluvias torrenciales que han provocado en Málaga nuevas inundaciones y desalojado a más de 3.000 personas tras declararse la alerta roja. Ante estos eventos extremos, cada vez más frecuentes y que afectan a todo el planeta, entendemos que es imprescindible, y como vamos a analizar en esta jornada, reducir las emisiones de carbono para reducir la temperatura del planeta. Resulta prioritario descarbonizar nuestra economía y mitigar el cambio climático. Nos enfrentamos probablemente al reto más relevante de todos los tiempos porque ya hemos comprobado que, lamentablemente, el aumento de la temperatura del planeta está provocando trágicas pérdidas de vidas humanas. Estos fenómenos extremos subrayan también la necesidad de contar con infraestructuras resilientes diseñadas, construidas, mantenidas y gestionadas en España por ingenieros de caminos, canales y puertos para garantizar la máxima eficacia y seguridad ciudadana. En el encuentro de hoy tendremos la oportunidad de conocer la Norma PAS 2080 desarrollada en Reino Unido y que plantea una nueva pauta en la gestión y reducción de emisiones de carbono en cada etapa del ciclo de vida de las infraestructuras. La norma, que se ha actualizado recientemente para incluir los edificios, considera tanto el diseño como la construcción y operación de infraestructuras y promueve la reducción de emisiones mediante procesos de innovación en toda la cadena de valor. Me gustaría concluir evocando la figura ejemplar de Agustín de Betancourt, fundador de nuestra profesión en España, que pasó periodos en Reino Unido y del que este año celebramos el bicentenario de su fallecimiento. El insigne ingeniero expresó que cuando la ciencia no se aplica a las necesidades humanas, podemos afirmar que su utilidad es muy limitada. Los ingenieros de caminos, los ingenieros civiles, reclamamos hoy más que nunca el valor y la aplicación de los fundamentos científicos y técnicos. Estoy seguro de que esta jornada será un espacio enriquecedor para encontrar claves que nos permitan diseñar un futuro bajo en carbono, es decir, que nos ayuden a proyectar el mejor futuro y el más seguro para todos. Muchas gracias.
Thank you, Mr. President. I would like now to invite Son Harris to take the stage and proceed with his remarks.
Buenas tardes, distinguished members of the Colegio de Ingenieros de Caminos, Canales y Puertos. Esteemed guests, colleagues and friends. I'm honoured to join you here today on behalf of the Institution of Civil Engineers. The Colegio and ICE share a long-standing commitment to elevating our profession and addressing the world's most critical challenges. Today our task is nothing less than transforming how we design, build and maintain infrastructure, with sustainability as our guiding principle. The urgent need for sustainable infrastructure has never been clearer. As our population reaches some 9.7 billion by 2050 and urbanisation accelerates, our cities face unprecedented demands. These demands bring with them immense challenges, but they also present remarkable opportunities. According to the United Nations Environment Programme, the construction sector is responsible for 40% of global carbon emissions, and about 11% of this total comes from embodied carbon, i.e. making glass, steel and concrete. This is particularly critical given that global construction activity is forecast to increase by 85% by 2030, just 6 years away. And that will be driven by urbanization and population growth. But in addition to emissions, we're also witnessing unprecedented rates of natural resource depletion. Our sector consumes 50% of all material extracted around the globe. And this demand is expected to double by 2060. That will have severe consequences for ecosystems and biodiversity. Water is another significant concern, with global construction industry responsible for 16% of global freshwater withdrawals. In Spain, these issues are closer to home, with this country facing some of the most extreme climate impacts in Europe. Over the past decade, Spain has experienced rising temperatures, more frequent droughts, unprecedented forest fires, which impacted over 300,000 hectares in 2022 alone. As Spain, along with Europe, do not reduce carbon emissions significantly in the coming years, scientists project a 2% rise in Mediterranean temperatures by 2050. These projections highlight the importance of taking bold steps now. At the Institution of Civil Engineers, we recognise that achieving sustainable infrastructure demands clear policies, professional development and technical guidance. Our work aligns with both the Paris Agreement's goal to limit global temperatures to below 1.5 degrees and the UN's Sustainable Development Goals. We recognise that innovation is a crucial driver in making sustainable infrastructure a reality. Digital tools, advanced materials and data analytics offer unprecedented opportunities to optimise designs and reduce environmental impact. Advances in material sciences are equally promising. For instance, switching from Portland cement to low-carbon cement alternatives could cut the carbon footprint of concrete by up to 40%. Researchers are also developing carbon-capturing materials that can absorb CO2 throughout the life cycle of a building. And additionally, bio-based materials such as cross-laminated timber offers renewable alternatives to concrete and steel. But the journey to sustainable infrastructure is one that no single nation or organisation can undertake alone. Collaboration across borders is essential. Europe's Green Deal, which seeks to make Europe the first climate-neutral continent by 2050, provides a framework for infrastructure that prioritises carbon neutrality, biodiversity and social inclusion. Spain's own ambitious climate plan aims to reduce emissions by 55% in the next 6 years. This reflects a shared ICE Colegio commitment to these goals. For ICE, we work to minimise environmental impact, but we must also recognise our responsibility to foster social equity. Globally, around 1 billion people still live without basic infrastructure services such as clean water, sanitation and electricity. Meanwhile, infrastructure inequality continues to exacerbate economic and social divides, both in the developing country and the developed world. To meet the needs of our communities, our infrastructure must be inclusive, accessible, and resilient. In closing, I want to emphasize that sustainable infrastructure is not a distant aspiration. It is a responsibility that we must fulfill today. The path ahead will require both ICE, the Colegio, and other global bodies to have courage, a willingness to collaborate, and a willingness to innovate. It requires us all to question established practices, embrace new methods, all with the aim of creating infrastructure that not only endures, but enhances our world. The Institution of Civil Engineers is honoured to stand by the Colegio. In September 2022, we signed an agreement of cooperation, and as such, this represents a powerful coalition of expertise and commitment. Through our combined efforts, I'm confident that we can build infrastructure that meets today's needs while safeguarding the future for generations to come. Señoras y señores, thank you for allowing me the privilege of addressing you today, and I hope to meet many of you at this evening's reception. Thank you.
Thank you, Son. And now it's my pleasure to invite Fernando Pons to share a few words with us.
Muchas gracias, Esther. Muchas gracias a todos por invitarnos. I'm delighted to be here. It's a pleasure for me and for the embassy to be invited here to speak, because I should start by saying that bilateral summits don't happen every day. We don't have many of those. Indeed, there's no such a thing as a bilateral political summit between the UK and Spain, believe it or not. So this is a fantastic opportunity. So in spite of the rather gloomy picture that, so I was struck by some of the data that you gave us. So is it true that, did I take you right, that 40% of the carbon emissions are generated by the construction sector globally? And that is meant to increase by 85% in 6 years or something like that? It's just amazing. It's amazing. I had a few data here to offer, which are rather funny. So I don't know whether I should go ahead or not, but anyway, well, just to reflect on the sort of the size of the bilateral relationship between Spain and the UK. There's no other two countries in the world that have more flights in between them than Spain and the UK. Not all arrive on time, but there's no other two countries in the world that have that many flights. The UK is the second largest destination of Spanish investment overseas, and the third largest investor in Spain. So the bilateral trade relationship is enormous. It's just enormous. It was worth in 2023 around 65 billion pounds, or is it pounds or euros, whatever. Anyway, it's bigger in terms of the British exports to Spain. That is bigger than the British exports to China and India combined. Nobody knows that. I mean, it's amazing how big it is. There's nearly 1 million people, 800,000 people live in each other's countries. So there's roughly 400,000 Spanish residents in the UK and a similar number of British residents here. So again, there's 19 million British tourists to Spain every year. 19 million. You don't get to travel that much to any other country. Amazing. Which means that the embassy has the biggest sort of consular section anywhere else. I mean, there's no other place that we have more people dealing with consular cases that we have in Spain. There's a huge demand here for instance, British schools and British language education. There's more British schools in Spain than in the rest of the EU countries combined. Again, it's amazing. So the list goes on. I mean, there's the links between the two countries are really, really very big. And still, or yet, there's no such a thing as a bilateral political summit. So I'm really glad that there is a bilateral summit here today. This event, though, comes out, as this has been mentioned by the Presidente and by Mr. Harris, as very timely. I think the Spanish Prime Minister has spoken loud and clear in COP29. Is it COP29? Yes, in Baku. It's happening as we speak. And it's made the case for the disasters that climate change can bring. I won't recall, as Presidente has done that already, the sheer number of people that's been affected by the floods in Valencia only last week, with over 200 or 224, I think, people who lost their lives, including 3 British nationals, by the way. So I welcome the opportunity that you guys have to discuss, share expertise and experience, and make the most of this event. So I think I shall leave it here. Thank you very much.
Thank you very much, Miguel Angel, Sean, Fernando, for enabling the collaboration between the two sister institutions, well, both countries, as a matter of fact. As the representative of ICE in Spain for the past 5 years, it's been truly an honor to see how both the Colegio and the ICE have strengthened their relationship. And I encourage civil engineers to become members of both institutions, because I guess that's where the value is. We certainly have a way of looking at engineering in different ways, but joining forces clearly is certainly a good thing. In 20 days, that's the 4th of December, we will be celebrating our 17th annual general meeting of ICE Spain, where we will be gathering to discuss matters that have been relevant to the profession over the past year. As part of the ongoing collaboration between both institutions, the Colegio has once more kindly offered their premises to celebrate it. It is an event that can be followed also remotely, so please be aware of the links that will be sent shortly. In this occasion, and in solidarity with the victims of the Dana in Valencia mostly, the AGM will be hosted from Valencia as well as from Madrid. So if you happen to be in Valencia, please pop up, and if you are in Madrid, same thing. This time, at the AGMs, what we do is we share some technical presentations. This time will be based on the challenges we face as civil engineers to promote safer and more resilient infrastructures in these times of climate change. So now, we're going to move on to our keynote on PAS 2080 standard. To do that, we have Luis Barlow. Luis is Technical Director of Decarbonization, Sustainability and Climate Change at WSP. We will also have Maria Manidaki, Technical Director of Decarbonization Asset Management at Mott McDonald's. Please, yeah.
Oh, we're there. Different screen. I'm with it, okay. Good evening. Thank you for volunteering to listen to me. I feel a great responsibility here because this is such an important topic, and I know I've been working in this area for years, as has Maria, and when you only get a small amount of time to convey all of the knowledge and trials and tribulations and problems and issues and barriers and successes and everything in a small amount, it's difficult, so bear with me. Also, I very much appreciate that you're listening in English, so thank you for that. So I'm Luis Barlow, as mentioned, thanks for the introduction. I'm also the ICE trustee for carbon and climate, so that's the kind of portfolio that I oversee. And I will be talking about PAS 2080, as will Maria in a moment. And so here we go. Okay, PAS 2080. It's not a very exciting sounding combination of letters and numbers, but it's really vitally important. It's absolutely central to the achievement of net zero, of decarbonization, and the avoidance of catastrophic climate change. Really, that's what this is about. That's what PAS 2080 is about. But I will try to give you the highlights, a very brief summary, then we're going to have a discussion all about it. And if there's anything that I mention, that we talk about, that you want to learn more about, please don't hesitate to get in touch. Okay, that's the main thing there. So, our engineering responsibility. We've known for years now as a civil engineering community, at least 10 years, that we are at the heart of this problem. we kind of think, oh, we're going to solve this problem, but we need to remember, first of all, we're part of the problem because we are associated with infrastructure, with the built environment, and as has been already mentioned, infrastructure and the built environment is responsible directly and indirectly for actually most greenhouse gas emissions, beyond 50%. If you take into account constructing it and operating it, and not just transportation infrastructure, but energy infrastructure, communications, water treatment, if you add it all up, all of this is civil engineering and engineering work, and it's responsible for most greenhouse gas emissions. So we have an engineering responsibility. This is the front cover of the NCE magazine from 2018. I'm sure you remember it well. This was about the time there was a bit of a change, a bit of a tipping point, and this recognition started to come out more, that we have this responsibility. In fact, the editor at the time, Mark Hansford, said decarbonization is fundamentally an engineering problem, a civil engineering problem at that. I mostly agree with that, mostly, because really at its heart, this is a STEM issue, science, technology, engineering, mathematics. It's really, that's what runs through addressing the climate emergency. But it's not just that, it's also behavioral, it's cultural, it's psychological, it's persuading people, it's behaviors. It's tricky. It's tricky. You don't see carbon emissions. You don't tend to they don't have an effect where they're released. There's a lag. There's all sorts of tricky aspects. A lot of the central emitters over the years have suppressed this knowledge. This is not controversial. We know this. We've known about this for a while. We're trying to get the message out there. So it's important. It's important to all civil engineers, and within the ICE, we did a survey of all members, I think it was this year, as to the importance of carbon in our work. Now, I'll summarize this graph for you. If you just look at the green bits of all of those bars, most people thought that it was at least important, if not very important, to their jobs and to their work. Most engineers, most members of the ICE. The snag was, and I won't go into too many more details of the survey, they didn't really know what to do about it. How do we actually, enact this? What do we do? And this is what PAS 2080 is all about. It's kind of a basic process for getting a grip on carbon in our projects and our programs of work. The other issue that we have in the UK, and I would imagine you have the same problem in Spain and other countries too, the decarbonisation bar is too low. By that I mean it's too easy to tick a carbon box on projects and then move on without really considering it properly. But carbon and carbon emissions, it's a pollutant. It's like another pollutant. This is polluting the atmosphere, this one. But if you were an industry owner and you were polluting a river, and then you said, well, I've been polluting the river, but I'm going to reduce the pollution of that river by 30%. The regulator, because there's probably a regulator, would say, that's not good enough. You need to reduce it down to the limit, the acceptable limit, or nothing, or you're going to get fined. You're in trouble. But in the carbon world, in infrastructure, if you can say that I've reduced the carbon in my project by 30%, you get a pat on the back. And you might even get an award for that. It's quite different. There are no limits for projects, for carbon in projects in the UK. I don't think there are really anywhere in the world yet. I think it's inevitable that that will come, and the prelude to all of that is measuring it and managing it consistently, which is, again, where PAS 2080 comes in. So there have been two versions of PAS 2080. The first one was published in 2016, and then the latest one published last year, new and improved. Still the same basic concepts, but some improvements. There are two documents. There's the main document here, and there's a guidance document that goes alongside it. The guidance document contains lots of case studies, examples of how to apply PAS 2080, and both are free and easily downloadable. Sometimes people find it a little bit difficult, even with the guidance document, to sort of understand really what it means and how to implement it, which is why hopefully we're here to start to talk about what it really looks like on the ground. It's a challenge to try and explain PAS 2080 in such a short amount of time, but I'm going to go for it in this slide. So I think of it in three simple parts. The first, and there's quite a lot to unpack here, but it's relatively simple in concept. Baseline your whole life carbon emissions impact. So within that, there's the concept of a number. Okay, so there's quantification that has to really be in here. This isn't acceptable just to talk about highs and lows and mediums and moderates and these kind of things. You have to describe things sometimes using adjectives. But we need numbers as soon as possible, right up at the start of the project. And whole life carbon as well. So you have to consider the overall impact of your project, as Sean mentioned, the embodied carbon, the upfront carbon, all the carbon that's been emitted up to the point of your opening ceremony, whatever the thing is, all the carbon associated with operating whatever it is you've built, and the carbon associated with decommissioning it, and the carbon associated with indirect effects of things that it might cause by adjusting a transportation network or whatever. There's nowhere to hide. It's the whole impact. That's what it's all about. You set carbon reduction targets. You understand what the impact is at the beginning. You understand the hotspots, and you target reductions. Now, we can talk about targets a little bit later on. That's an interesting subject. But the targets will drive you forward, and they have to be stretching. They have to pull you in the right direction. They shouldn't be easy. And then just proactively manage that carbon reduction across the supply chain. So you work it all the way through the supply chain. So everyone's involved, not just an enthusiastic consultant or an enthusiastic client. Everyone's involved, and contractually. And we'll talk about that later on, the procurement side and the contract side. So that's really it, 3 parts. Leadership guides it all. This has got to come from the top, got to come from the top of the supply chain, got to be seen to be coming from the top as well. Otherwise, it sort of undermines the importance of it going through the supply chain. Quantification, as I mentioned, and challenge. Challenge is mentioned almost 20 times in PAS 2080, which is really unusual for a specification, a standard like that. Challenge is there so often because the standard recognizes, as we all do, that the system, the way we do things at the moment, is unsustainable. So we can't carry on doing things the way we currently do them. So challenge is encouraged. You know, contractors can challenge their product suppliers, the designers can challenge the client. Everyone's challenging each other, hopefully in a polite way, so everyone still wants to work with each other, but it's a recognition that things need to change. And personally, I think quantification is key. You know, numbers, not adjectives. We really need to get to grip on the numbers here, and PAS 2080 sets that out. A couple of highlights in the new version. There are lots of new things, but here are some things I think are particularly important. It covers the entire built environment. So the first one was called Carbon Management and Infrastructure. This is buildings and infrastructure. In other words, everything that can be constructed and operated can be encompassed by PAS 2080. And every standard or approach to decarbonizing little bits and pieces or certifications and everything you can think of is compatible with PAS 2080. PAS 2080 just sits above it all, just to ensure that it's all pushing in the right direction. It recognizes net zero, which came into force legislatively in the UK, oh gosh, I should know this, 2019, thank you. So this is another change that we're really heading towards net zero, and PAS 2080 can help with that. And system level change, which I think we'll probably talk about again later on. PAS 2080 is not just about decarbonizing bits of concrete and steel here or there, on little projects over here and there. It's about choosing the right project to actually implement at the beginning. That's when it's most powerful. There's a new section on procurement and decision-making, and its modular approach, this might sound a bit jargony, its modular approach to whole life carbon is now compatible with almost everything else. So if you're a client and you don't really understand this in too much detail, it doesn't matter. If you're asking for PAS 2080 and you've got a building being built over here and a bridge over here and a water treatment works over here, if everyone's following PAS 2080, you can add it all up in the same way on a spreadsheet or whatever you want to do. It's consistent. There's a summary. PAS 2080 promotes reduced carbon, increased value delivery, more collaborative ways of working, and a culture of challenging convention and traditional practice for decarbonisation. I just have a couple more slides here. Again, I'm not going to go into the detail of this, but just suffice to say, this is the picture of whole life carbon. So think of it as A, B, C, D. A, before use, B, use, C, end of life, and D, knock-on influential effects beyond the system boundary. This is really important. You don't need to understand the ins and outs of it. Suffice to say, as I said before, there's nowhere to hide. You can't greenwash this. This is really as close to the truth about the carbon impact of the things we're designing and constructing as you can get. applies to all the value chain set out as clients or asset managers, designers, contractors, product and material suppliers, and there are requirements for each of those value chain stakeholders. This is the hierarchy of carbon reduction, which stems from, if you go way back in time, a similar graph, similar schematic graph that shows the diminishing ability to influence cost as you move through a project's lifetime. Same thing applies to carbon. The later you leave it in a project's life cycle, the less you can do about it. So that encourages us to think more about it right up front, right at the beginning, when we can make the most difference. Firstly, by questioning the need. Do we even need this thing that we're talking about building? Only when we really definitely need it can we work out how to decarbonize it and build less and improve it. This is a QR code that relates to X29. So there's these two important clauses on procurement and integrating carbon into decision making. X29 is another word and number combination that doesn't sound very interesting, but also is very important, because when you combine this secondary clause to the new engineering contract with PAS 2080, you get a very powerful mechanism to make it happen, to give teeth to all of this, to really make sure it happens. The ICE, we issue the State of the Nation report. Again, that's a QR code if you want to download that. And there's quite an important part of that, which stresses the importance of all of our members to recognize the role they have in all of this, in helping to decarbonize our country through infrastructure decarbonization, but making carbon management mainstream. All members are expected to take steps to align their technical and professional practice with PAS 2080 principles. Okay, and I will ask you, we're nearly there, Maria, nearly there. It occurred to me, a really important point. This is not just for environmentalists or your environmental discipline or an environmental team. It's most powerful when the PAS 2080 process is pulled right into the center of the project, right next to cost. And in fact, if you walk away tonight, you're thinking, what was he going on about PAS 2080? I don't understand it. Just treat carbon like money or cost, and you'll be on the right track. Same kind of idea. You want to minimize the spend. You've got a budget. You want to try and spend less. You're keeping an eye on the money all the way through the supply chain. How do you do that? It's very similar to carbon. So we're looking for best practice examples. If you have any, I'm going to change the language here. Not necessarily even best, just good practice, or things that you think you might have done or experienced, or you're aware that someone else has done, that you think, that wasn't perfect, but it might, if we did that again, if we shared that information, maybe someone else could do it better next time. So we're always looking for examples like that. You can always email me, or more formally, Sam Hall, who is the ICE's new Carbon and Climate Knowledge Lead. So he's assembling all these case studies. And the final slide from me for now, PAS 2080 is about decarbonization principally and trying to mitigate catastrophic climate change. There is let's call it a sister PAS, which is about to be developed, which is going to deal with the adaptation side and resilience and adaptation pathways. With a little bit of luck and fingers crossed and a few more euros, we'll get this across the line soon, and it will be under development next year. So if anyone would like to volunteer to chip in a few euros, please let us know. We're almost there. This is arguably, well, at least equally as important as PAS 2080. And with that said, finally, I will hand over to my peer, my friend Maria, who's going to talk a little bit more about it from perhaps even more practical perspective. Over to you, Maria. Okay.
Thank you, Luis. Hi, everyone. Hi. Great to see all of you here in your amazing city, Madrid. You can tell from the accent I'm not British. I was born and bred in Athens, in Greece. So I was also having the joy of working with Luis for many years and many other colleagues in the industry, and being in the technical author team for PAS 2080. So yeah, hopefully I can give you a little bit of a view of practical things we're hearing in the industry from different members of the value chain of what do all these things that Luis very eloquently described on PAS 2080 mean in practice, okay? So as Luis told us, that the whole point of PAS 2080 is how do we align the objectives for carbon management in the value chain, the colored bubbles in this slide. It also recognizes, though, the importance of government, regulators, investors, academia, and other players, and how essentially all these people in the colored bubbles can also influence each other, but upwards towards policy setting as well. And what I want to give you now is some practical things we're seeing day in, day out of what all these things mean in practice. So I want to start with the asset owner. So I am an asset owner. Let's say I'm a water company, I'm an airport, I'm the Ministry of Transport, I'm the Ministry of Environment, owning and operating and developing infrastructure assets. Where do I start with all this in PAS 2080? So if I was to summarize this, which is a very fair challenge, I would say, first of all, think, as Luis mentioned, whole life carbon. Think your emissions around constructing the asset or the portfolio you have. Think about the emissions associated with operational emissions like energy, chemicals, can be other direct things like land use change when you disturb the carbon in the soil. But also think of the user emissions. If, for example, you're the Ministry of Transport and you're planning expansion in a highway, think of all the emissions associated with the petrol in the cars. These are emissions that are not in your direct control, but are emissions that you're responsible for and equally able to influence. So if you're an asset owner and you start from zero, what would be a practical thing to do? First of all, like Luis said, similarly to cost, plot your capital investment plan for the next 10, 20, 30 years. Capital cost, operational cost if you have it, and then try and understand through very basic carbon data information, and PAS 2080 guidance document has got some databases there. Get some help, try and understand where the hotspots are of this carbon. You don't have to start with fancy databases. This will come for carbon, but start with basics and understand where is the carbon. Is it because I'm building too many pipelines, too many tanks, road surfacing areas, concrete, steel? Where is it exactly? Energy, chemicals. And by that, you will be able to see, okay, so if I don't have a target and I need to set a target, having one target by 2050 being carbon neutral is not good enough. We need to have interim, short-term, and longer-term, medium-term targets and try and understand how we're going to meet those hotspot reductions in our emissions. That's basic number one. And the most important thing, before you even start complex commercial models with incentive mechanisms linked to carbon emissions data, at least ask your suppliers to start thinking about how to reduce those hotspots. And as a minimum also, don't block them coming to you to suggest alternatives in their bid responses for lower carbon alternatives as a minimum. Hopefully, this is a question that I keep hearing all the time. If I'm a designer and my client isn't asking me to do anything on carbon, what do? How do I start influencing? That's another very common question we're seeing in the industry. So Luis mentioned the carbon reduction hierarchy. Luis also mentioned that the carbon problem is not the problem of a sustainability manager only. It's all for all of us engineers. And we all know that us engineers are very good at really challenging the resource efficiency of our projects and come up with some brilliant innovations. So what if we actually, in our value engineering meetings, we had a carbon lens to those, and we follow systematically through our project designs the carbon reduction hierarchy and asking key questions that there is some guidance in the guidance document of PAS 2080 of, do I need this thing to build? Or my client says, yes, I do. Okay, so can I avoid building new piles in this rehabilitated site? Can I reuse any of the existing piles for the avoid? Or can I use different materials for these tanks or pipelines in the switch category? Or bring alternative chemicals or other things. And by that, I have seen in practice, by looking at the problem from a carbon lens, you come with even better efficiencies, better innovations. And then again, use some high-level carbon data. There are some examples in the guidance document to really understand what is approximately the carbon reduction potential of those solutions and the cost impact, and prioritize by communicating to your client through your design meetings the opportunities that are low carbon, low cost. As a starting point, if you manage to do that, that's a brilliant start. If I'm a contractor now, and I'm a major contractor, I work with my suppliers, we have an excellent relationship, and we know we're involved in all these mega projects in Spain, in the UK, in Greece, in Portugal, wherever in the world those are, bridges, roads, whatever this may be. And we know that we're going to need a lot of concrete. We know we're going to need a lot of steel. We know we're going to need a lot of construction fuels to build these things. So we know these are going to be likely carbon hotspots. So what do I do about those? Because we know there are alternatives in the market, like alternative binders for cement and concrete, alternative ways for greener steel, hydrogen for fuels. But these things cost a lot at the moment, today. And these things are not available at scale in the market. On the left-hand side, you see a couple of things that is a great initiative that the ICE has been instrumental as well. The low-carbon concrete route map, where essentially it mobilized the industry, major contractors, product material suppliers, and asset owners to really understand and gather the evidence base for key materials like concrete, and the other one is for fuels and steel, etc., to start asking for these things 10 years before these projects are going to be constructed, to send the right market signals and accelerate the creation of those markets so the costs can go down. Similarly to solar energy, for example, that was the case 20 years ago. And last but not least, a very complicated point around, okay, if I'm an asset owner again, how do I influence policy for reducing whole life emissions? Because a lot of the times, as Louis said, especially carbon emissions, these emissions are not regulated. There is a national legally binding target, but I'm not going to get fined if I don't meet this target in my organization. So how do I give some insights to policymakers and government through my capital investment program that could be huge if I'm, for example, the Ministry of Transport or the Ministry of Environment regulating for water? So if I plot my emissions for capital carbon, operational carbon, user carbon to 2050, let's say 2040, whatever that may be, and I superimpose that red line, which is the national legally binding target, how do things look like? Even if I have this at the basic level, can I start the conversation with the policymakers and government, together with other asset owners, to show the picture that things are not going to be easy to do? And these are the little knowledge bites we want to give you with Louis on PAS 2080. Hopefully it starts now to make a little bit more sense. But yeah, thank you very much for that, yeah.
Thank you very much, Luis, Maria, for such a useful insight on PAS 2080. So we're going to start now with the panel discussion for a low carbon future, innovation and sustainability for a low carbon future, which will be moderated by Arcadio Hill. Arcadio Hill, he's a civil engineer and economics degree. He's chair of the Senior Council of the Urban Land Institute in Spain and elected member of the board of the Colegio de Ingenieros de Caminos. The panel will be formed also by Maria and Luis, whom you have already met, as well as Marta Pertierra, Infrastructure Resilience and Asset Management for ICE Ingenieros Consultores, César Bartolome, Technical Director and Innovation Manager of IECA, and Leonardo Todisco, Associate Professor of Structural Engineering at Universidad Politécnica de Madrid. For those who are joining remotely, well, if you want to place your questions, you can do so on the platform, and then they will be aired out at the end of the meeting. So, welcome.
Thanks. Thank you very much, Enrique. Good afternoon. It's not working? Okay, now. I'm fine, thank you. Good afternoon, everybody. For me, it's a pleasure to be here. I have to say, I don't know if you realized, on the magazine picture, you have introduced at the beginning of your presentation, it was said, urgent call of action for civil engineers. This is what was said in the magazine. Then it's really appropriate for all of us, to have the opportunity to listen to you, and now to have the opportunity to share and to extend the comments about this standard with this so representative round table. Thank you, both of you, to accept to be part also of the panel. And I also noted that you said, he said on the first slides of the presentation, said Luis, Mr. Barlow? Luis said decarbonization is fundamentally an engineering problem. You said this. That's why it's really interesting to have this opportunity today. Now, the three civil engineers that are joining the panel now, I would like the three of you to introduce yourselves. I don't know if I can start with Leonardo in this same order. Leonardo, you are a professor in the Universidad Politécnica. Could you introduce yourself?
Yeah. Good evening to everybody, first of all, and thanks for inviting me. My name is Leonardo Todisco, and I'm a professor at the Escuela de Caminos, Canales y Puertos here at the Universidad Politécnica de Madrid, which is the civil engineering school of the public university in Madrid. And I work in the area of structure engineering. So I teach concrete, steel, composite, rehabilitation of existing structure, this kind of stuff. And I represent somehow a little bit the vision of the design. So I've been really involved in the sustainability matters, more related to how we can, as designer, have a real impact on this. And I have to say that I don't have an answer. Okay. Thank you very much.
Thank you. Marta, you are part of one of the best known engineering firms in Spain, in Madrid, ICE Consultores. Can you introduce yourself, please?
Sure, thanks. Thanks also for inviting me to be part of this roundtable discussion. I am a partner and an engineer project director at ICE Ingenieros Consultores, and I come here to the roundtable from the asset management perspective. In ICE, I work mainly in advanced asset management systems, so mainly for asset managers and asset owners. And in this discussion, I would like to give that vision or approach of the whole life cycle approach in carbon reduction. I don't know if maybe most of you know ICE Ingenieros Consultores. We have been working in infrastructure maintenance and asset management for over 20 years and always looking for innovations, whether it is with new technologies, machine learning, artificial intelligence, resilience. And in this case, we are also integrating carbon footprint and sustainability in asset management analysis. So that's why I'm here.
Really interesting, Marta. Thank you. Cesar, you have to excuse me, but it's much more complicated for me. You are coming from IECA and OIC. Please, could you tell us what's this?
Thanks so much for the invitation. Not that difficult. I come from the Spanish Cement Institute, so I represent the materials part, and one of the materials that are, let's say, blamed for, or partially blamed for this climate change and this global warming effect. And that's one of my part, and basically, that's my job, okay? And we are basically focused on, our part is just, our mission as the Institute is to collect knowledge, to generate new knowledge. We participate in innovation projects, European projects. We collaborate with universities, and we have to transfer that knowledge to the market. So now, for the last, I would say, 10 years, our main focus has been on decarbonization. I think I entered the sector in 2008, and probably 2013-14 was the change. And now we are working on that, on developing new products or decarbonized products, so how to reduce not only the footprint, the carbon footprint of the materials, but also the carbon footprint of buildings and infrastructures with new designs, innovative designs, and so on. So we are mainly focused on that, and the other part is just part of my spare time. I mean, I collaborate with the Open Innovation Community. It is a group of professionals that we try to foster innovation, and that's in my spare time, in my weekends.
Thank you, thank you. I like this expression that is on this standard all the time mentioned, no? Value chain organizations. We have, I don't know if I'm going to remember, you put four circles for type of organizations, suppliers, designers, constructors, and managers.
And clients, yes.
Somehow.
Yes.
Huh?
Yes.
No, basically, okay. No, what I want to say is that we have, with those three engineers, we have three of those four organizations. No? Then I would like to start to first put the question to the designer, no? To Leonardo, no? Which are the main challenges these project and design organizations you have to face in the future in relation to this subject?
Well, first of all, I think that the methodology that is included in the PAS 2080 is somehow very, the approach is similar to the European norm 15643, I think. So this helps a lot. So basically what we have seen before, that for example, we have the production material, the construction, then the use, and behind the use, etc. So this is, the methodology is very easy. Although I think there are some challenges, and always the devil is in detail of the methodology. I will provide just a couple of examples. The first one is the time frame, because technically we should be able to measure the CO2 emission along the whole life of a structure. But what is the service life of the structure? Is 50 years? Is 100 years? Maybe we can say that for all the bridges is 100 years. But if I am a good designer and I do a very good detailing, or I use some very good materials, and I'm able to guarantee a longer life, my service life is not 100 years, maybe it's more. So it's not easy to understand how much is the real service life. And then there is another issues which is related also to the behind of life. Because we have A, B, C, which is pretty easy, and then there is D. What happens when the life is over? And there are many calculations, especially in bio-based material, timber, that say that basically the material is able to absorb CO2 during the whole life. But what happens if in the end of their life it is buried? The CO2 is again relates to the atmosphere. So it doesn't make sense to consider this absorption if in the end we are going to bury it. So these are, there are some details which are not very easy to understand and to put in practice. Yeah.
Thanks, Leonardo. Then you are talking about life cycle, asset managers or owners. Marta, what is for you your vision on this?
I would say that designers have a say in the extension of life cycle and lifespan, but asset managers and maintenance strategies have a lot to say in extending the lifespan of infrastructure. And that's, I think, where our people, asset owners, asset managers, and consultants that provide knowledge to those people have a lot to say. Especially in countries like Spain or the UK, where we have very mature infrastructure systems. So most of the buildings and infrastructure that is going to exist in 2050 is already in place. So all the opportunities that we had with designs and new constructions are not really there anymore. What we can do is reducing the carbon footprint during the maintenance and management of this infrastructure. And how? Working in two ways: with the operational part, so reducing the operational carbon footprint, which is mainly for buildings more than for infrastructure, because in our case, in transport infrastructure, it's very limited, and then with good maintenance strategies, advanced maintenance strategies that can extend those lifespans. That maybe, and a good example, if I may, is railway bridges, where they were designed for maybe 50, 100 years, but 1/3 of them in Spain are over 150 years old. What can we do with that? We have to keep extending those lives, adapting to the new functionalities needs in order to reduce or avoid reconstructing them.
Thank you. Suppliers, no? Is your turn, César?
Yes, that's where we are working, and I think we are quite both, I agree with both a lot, because what we are trying to do, it is when we are in our strategy, decarbonization strategy, of course, we are trying to reduce the carbon footprint of our materials. But at the same time, we must for sure keep, but improve to the performance of those materials. We are talking about whole life cycle. We are talking about increasing the durability of our materials. And I think that both things are compatible. We cannot just, or we mustn't choose between one or the other, because we are tempted to do so when we have to reduce the carbon footprint of, cement, concrete, or any other construction material. We can say, okay, I reduce it, but I am limiting the performance of those materials and the durability of those materials. I think that is a completely wrong approach. We must be able to reduce our carbon footprint. At the same time, we are increasing the durability of those materials, and we are increasing the performance, resistance, functionality, because infrastructures will last for 100, 150 years, and for sure the use that they will have in 100 years is totally different from the use they are having now. So we must to design new materials that are, allow to design new structures that are flexible and that can change the functionality along their service life.
This is right, thank you. Speaking on this, perhaps I can put the question to you, Luis. Why has been introduced procurement on the standard? Why is so important for you?
Sure. Can you hear me okay? Yeah. Sure. Okay. Yes, it's a new clause. It makes it sound like a paragraph, but it's a new section. So it's important because a lot of this work that we're talking about, the decarbonisation efforts and projects, has been voluntary, really, over the years. I'm sure Maria had the same kind of feeling years ago. We were doing stuff that, frankly, wasn't getting paid for. We were pushing the envelope in our spare time almost, but that's not sustainable. And at some point, somebody has to, pay for people to work this out and pay for low carbon solutions and make sure it actually happens. So it needed to become contractual. So that's really why the new procurement clause was included, to make it happen. Otherwise, people might just forget about it or push it to one side.
Okay, good. I left you. How should I pronounce this? Because you are coming from Greece. It's Maria.
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 Like in Spanish, yeah. Same.
Then the question is if I ask you for one, which for you would be the most challenging issue, in the standard?
Okay, so if I had to pick one, from what I've seen is that I know we're engineers, we love numbers. I know, Liz, you told us we need to look at numbers. Absolutely, agree totally. But if there was one challenge, I would say we need to really focus on the numbers that will make a difference in the decision-making process rather than all the numbers. You mentioned, Leonardo, about the end of life challenge and some materials recycle end of life, biogenic carbon, etc. Does it make a difference? Is it a big hotspot in whether I choose option A or B? Same with materials and durability and design lives. Yes, choose some scenarios, run it for 200 years, see if it makes a difference, option A to option B. There is not enough time. If we're, as a continent, as a planet, we're to meet the Paris Agreement 2050, we really need to halve our global emissions in the next 5 to 10 years. So we need to really use this time wisely to focus on detail that will make an impact on decisions. And that's, I think, it's the biggest challenge. It's a cultural challenge.
Thank you. Speaking, Leonardo, on the design field, how do you think that you could overcome this challenge?
Sustainability is basically 3 pillars, right? Social, environmental, and economic. If we consider the environmental part, specifically the CO2, without considering the other, it will not work. And of course, someone can say, you have to maximize all these pillars at the same time. But this is not possible. I will provide you an example, very easy. A few months ago there was a ship that basically hit a bridge in Baltimore and it collapsed. Maybe you remember. So basically, at that time I was a visiting professor in Zurich, and there were some journalists that asked if we as civil engineers are able to design bridges which should stand for these loads. Of course, there are solutions for that, but they are expensive, they increase the resilience, but they have very bad consequences in other pillars. So we cannot consider all this at the same time. So it's our own responsibility to define which are the important criteria that have to be prioritized in each specific solution. I think that's important.
Absolutely.
Thank you, Leonardo. Please.
Just another challenge, which is similar to what you're saying there. Maybe you can learn from my bad experiences, but when you're trying to push something forward like PAS 2080, you're trying to explain it to a project manager or trying to explain it to a client, sometimes, ironically, it might be an environmental person that will pop up and say, but it's not just about carbon, it's also about society, and it's also about these other environmental issues, and we've got to consider this and this and this, and we shouldn't have carbon on the agenda, it should be sustainability. And while that's true, we do definitely need to consider all these things. There's only a certain time in the... Oh, thank you, that's better. There's only a certain amount of time in the day, people only have a certain amount of time in meetings, and in my experience, if it's like an achievement, like level 1 achievement to get sustainability on the agenda. Usually it's the last thing on the agenda before any other business, and the meeting normally runs out of time. Sorry, we've only got 2 minutes for sustainability. But really what you want is carbon on the agenda, and then you can push it forward, and you can use PAS 2080 as the lever, because it is a very technical sounding standard, which sometimes helps.
Yeah.
Then talking about this consideration and looking at the long term, as the asset managers have to do, which is the balance you made about those reduction of carbon emissions.
I was thinking now about what Luis and we were saying, and Leonardo was saying. We have a huge challenge, I think, and we have seen that recently, like 2 weeks and last week in Valencia and in the south of Spain, like how to balance mitigation to climate change and adaptation to climate change. And they are 2 things that are necessary, but do not require the same approach. For increasing resilience so that we don't see our infrastructures collapsing every time we have extreme event, we need to put money at first, and we have to emit carbon. But that needs to be balanced in the long term to mitigate carbon emissions. So we need to have like that twofold vision when analyzing asset management and maintenance strategies. And I think like it has not been done at present. We are doing a great effort in order to include those 2 concepts into asset management and maintenance planning, but it's something that administrations and owners have to really embed and buy into.
Marta, would you like to add something?
Yeah, so Marta, that's a really important point you make, and I just want to say that in the revision of PAS 2080, we really try to encourage that direction of travel, of looking at total value and resilience, decarbonization, nature, and circularity, and that's the key challenge, the decision-making process. Do you monetize all these things? How far into the future you assess that? it's very difficult, but we need to start as engineers, we need to start thinking along those lines. You're absolutely right. It's not easy, eh? Nobody has the answers.
If I may, for example, resilience, that I don't know why, but I feel like society is a bit more concerned about resilience because we are seeing the impacts, and it's very close now in our own country, and we are achieving that asset owners and managers include resilient analysis in asset management. So that is a good point. Now we are moving towards the next step, which is incorporating mitigation to climate change through carbon footprint.
Mm-hmm. Thank you. And Cesar, how can companies collaborate with the suppliers? How can the companies collaborate with the suppliers? What's the role you can play?
I think that we are working on the solution. I think that resilience is important, quite important, I'd say. I don't know as much as mitigation, but probably kind of. And what you said, okay, to make our infrastructures more resilient, at the end we will have to emit more CO2. Yes, probably yes. But I think that we have to, as I said before, we have to improve the performance of our products, of our structures. At the same time, we are reducing the carbon footprint. I'm talking about my book now. We are talking about cement, concrete. Maybe we have to change the way we look at the problem. So far, we have used, probably 90% of the cement that we used is Portland cement, and we have alternatives. Maybe not for all the solutions. Maybe we have to keep that Portland cement for specific solutions, pre-stressed structures, or some structures in which we need ultra-high resistance concrete. But there are many situations, many structures, many civil works in which we can use cements that are available now, concretes that are available now, that can give us that performance for resilience. At the same time, they have, 30 or 40% lower carbon footprint. So I think those things are compatible, but we have to find a solution to do it. It's true that there's one thing that you said that probably is more difficult to make compatible is the price. It is the economic part of the problem. Of course, we are trying to develop this. The sector, the cement sector, concrete sector, they are trying to develop these new materials, but that means a lot of investment. Just to give just a picture, a cement plant costs around, 150 million euros. A carbon capture plant costs around 300 million euros. If we are trying to decarbonize the cement and the concrete sector, we have to invest a lot of money, and we are only talking about CapEx, not OpEx. So how much is it going to cost? I don't know. We don't know it yet, but for sure that part will be also important.
I like that you arrive at this point because cost and benefit, at the end is one of the big issues, in relation to all this. And I have here the question for you, for the both of you, Luis and Maria, how do companies balance, the costs and the benefits, in relation to how can they balance this so difficult issue?
Do you want to go first? I'll go. This is a deep issue, deep one. Right. But the high-level rule of thumb is reduce carbon, reduce cost. Just like if you had to summarize it in 4 words, it's not always the case, but a high-level rule of thumb, especially in infrastructure, big civils, where it's big concrete quantities, tunneling, digging things, moving stuff around, if you're reducing those things, you should save money and it should save carbon as well. That's more like a project-specific basis. There comes a point where, on a project, you will start to hit materials, low-carbon construction techniques that cost more. We've been alluding to them earlier on. We call that the carbon cost tipping point. It's the point at which it starts to cost more to reduce carbon further. So the real trick to all of this is to consider carbon and cost together from a very early stage, central to the design process, so you can balance these things together. I think really the sort of heart of your question was almost for an organization, how does an organization justify that? Well, again, I would say the rule of thumb would be it's worth it. It's not going to cost very much. You're probably doing these kind of things anyway. It's a way of standardizing them. And the other benefit would be it's foreseeable in the not too distant future. If you're not doing these things, you might not get the contract because the client will eventually be asking for these things and you'll be out the picture.
Maria?
Yeah, To add to what you said, Lucy, I agree. What we have seen is that when people are starting out, the good thing about looking at carbon as a metric, whole life carbon, is that it gives a resource efficiency lens to a problem, rather than if you have only cost, which depends on market forces, et cetera, squeezing suppliers, et cetera. And that means that a lot of the times I've seen from people starting out, they realize at project level a lot of efficiencies they wouldn't have, and asking them to revisit asset standards, whether they're still valid. Some of them are like 40, 50 years old with the technologies we have. However, the point you mentioned about carbon and cost tipping point is absolutely valid for capital carbon especially. So that's why the whole life view is so important when we mention about service lives. And then if it's justifiable on a whole life basis, you have to have the right incentives in your contract to be on a whole life cost. And then who pays for that? And that's why my point earlier in the presentation around policy and decision makers, if you start discussing those things with numbers, that's when the case maybe will start coming, like we had exactly the same point with renewable energy and solar, and feed-in tariffs kick-starting the market basically and dropping the cost by achieving economies of scale.
Thank you. Please.
I was thinking, when we talk about costs, okay, maybe we have to think how much money we're spending now in Valencia. And maybe that must go into the equation, okay?
I was going to say exactly the same thing. Like, if we had adapted those infrastructures 1 year ago, would have we spent the same amount of money of rebuilding those infrastructures, no? So in the long term, it's more expensive not to think about these things.
I add, just a very small thing to that. Very soon, I think next month, the Swedish Traffic and Transport Administration, Trafikverket, are going to publish a report. They've been investigating, it's called the cost of transition, the cost of net zero in infrastructure. And the Swedes are a little bit ahead of the UK in their approach, same sort of approach that they're taking, but they've identified these things, and they're coming to the conclusion of, if we're looking at low carbon things, what's an appropriate price to pay, for these different things versus other things. If we're an infrastructure government organization, we have a responsibility for healthcare and education. How can we justify paying this for low carbon stuff? So the Swedes are going to publish this report next month. I'll get a hold of it. I'll put it on my LinkedIn or something. We'll share it somehow through the ICE. I think it'll be interesting.
I think it's going to be good, yeah? If we are talking now about measurement, no, because in fact, one of the key elements, to achieve this low carbon feature, of the title of the session, is to measure what we are doing. I can start with you, perhaps, Cesar.
Okay.
How does material sector contribute to this?
I think we have the tools to measure it. We have the EPDs. We have, and we can just build up the whole structure, from these little bricks. And that's all standardized. All the construction material products speak the same language in that sense. So we can compare things. I think we have already done that work, and that's available. Here in Spain, we have a lot of sectoral EPDs. We also have individual EPDs, and that's available for the designers, that's available for the procurers, just to try to implement these metrics into the public procurement. That is, the tool that must track the rest of the market. So I think we have the metrics, we have the way to measure them, to measure the carbon footprint, and not only carbon footprint, because we have many other parameters that are included in EPDs, and we just have to make use of them, I think.
Thank you. What about Marta, about asset management? How do you think are the main measurement issues you have to deal with?
I feel like from our side, on one hand, we have our asset management systems where we have all the data of our assets and the infrastructure. So we have the year of construction, typology, material dimensions of the assets. We have all the interventions that have been done in that asset. We have the cost of the construction. All kind of data of the infrastructure that will allow us to estimate the carbon footprint. And on the other hand, there are new tools in the market that allow us to do those calculations. So basically we have the two components and we just need to integrate them into a single tool. The beauty of software nowadays is that you can link them so that you can extract the data from your asset management systems, feed it to these calculations, and then input it again in your optimization algorithm and your maintenance planning. So I feel like we are going into that integration, but the tools are already there in place.
Thank you. And in the design field, Leonardo, on this field, what are the main obstacles you can find? No?
I will provide an example, a bridge. I will say that probably 80%, 85% of the CO2 is emitted during the construction, but in the product and construction. But the cost is probably 50, 60% during the construction, and then we have the maintenance cost, which can be around 1% of the cost for each year. So that means that if we have 100 years, we have basically 50% of the cost. That means that we don't have only to see to the CO2, because maybe we have some solution, and we have this kind, for example, integral bridges, which generate a little bit more of CO2 when we start, because we need some more reinforcement, etc., but we can reduce a lot the maintenance. So we should have a look to the whole picture, putting together the CO2 and the cost together. That's simple.
Thank you. And you, Maria?
Yeah, whole life carbon, as we said, top consideration. If there was one thing to learn today, it's whole life carbon. That's all it is. Right. And I think for me, from what I've seen in practice, as you said, there is quite a lot of information out there, carbon data from suppliers and then for operational aspects. But what is missing is data that is readily available as a benchmark during the planning phase of a project, like, do I need this bridge in the first place? Or do I need to increase capacity in my transport network, move people and freight? Do I go by expanding the highway or go to electrified rail? You know, the benchmark, like off-the-shelf data there, which is a so important thing at the early stages, like Lewis told us, to avoid things, is missing. And this is something we're having conversations in the ICE and other players in the market to really start creating those industry benchmarks to help with decision making. Yeah, that's.
Thank you. Luis, would you like to add something before going into a new chapter? One of the last ones. Measurement.
Measuring. The new PAS 2080, the updated one, has got something. You mentioned EPDs, so environmental product declarations for products. The draft of the new PAS 2080 said all product suppliers shall produce EPDs. And then it went out to consultation, and then it got a lot of feedback from the suppliers community that said, we can't do that because we're developing innovative things, there are not enough auditors, how are we going to do this? So the new PAS is more reasonable, and it says that product suppliers should be able to demonstrate that they're working towards an EPD or equivalent. So it's not prescriptive. The PAS does recognize that, you know, we're working towards improvement in this area.
Thank you. Last chapter, no, is this national perspectives. You have already talked about Sweden, no, minutes ago, but in general, no, have you got experience on governments in the region?
Yes, a couple of quick ones. I worked in the Scottish government for a couple of years, was seconded in to help weave decarbonisation into a £5 billion capital investment programme, where carbon wasn't really there before. And I think the presumption was that we could rely on the environmental impact assessment process and normal environmental things, but we can't. We need to weave PAS 2080 in. So I helped to weave PAS 2080 into the guidance for that program. That's been very successful. So successful that an organization that was pretty anti the whole program from a carbon perspective is now fully supportive of that approach and is mandating this across everything else in the government. One more quick one, which is the Australian government, Infrastructure New South Wales, has looked at PAS 2080 in a lot of detail and has recently published policy on carbon, including embodied carbon, that builds on PAS 2080, takes it to the next level. That's due to become mandated in New South Wales from April, and it's likely that will be rolled across all of Australia. So that's another key point. The PAS 2080 document is applicable anywhere in the world to any kind of project. It's totally proportionate.
And perhaps this is the time now to put the question. I would say to everybody with your experience, what would compare the difference between the implementation of a standard like this between UK and Spain?
Well, I will say that the framework behind the PAS can be applied almost everywhere because it's perfect. However, just two things. In Spain, I think, probably also in UK, we don't have a clear strategy from the government, you know. There is no clear plan about that. And also that means that because the owners of the different assets are different, AENA, Renfe, Puerto de Estado, Ministry, etc., they may have different priorities. So they can take decision instead of others. This from one side. And then that the organization, especially in Spain, we don't have big office of designers, as for example UK, that's pretty small. That means that if we don't receive some incentives, some help from the government, it's very difficult to put some people, some resources specifically to that topic. It's not so easy.
Please, Marta.
Yeah, then we need like a standardization and regulation, so that is kind of like ask from, as you were saying in your presentation, from top level down.
Yeah, I mean, as optimistic as I am, I don't think we're going to get to net zero without regulations, especially when sometimes it's more expensive. So we need rules and regulations and economic drivers to push it forward, which needs to come from governmental level.
Cesar, would you like to add something?
Mostly everything has been said, but I would focus also on training. I think it is important because, I mean, one of our mission, of our tasks, everyday task, is just to answer questions. I mean, to professionals that come to us. I want a low carbon cement. I want a low carbon concrete. And at the end, the same question, I always ask the same question is, what for? Okay, because it is not the same. I mean, every project needs specific attention. It needs a specific solution. So I think that training is important just to, for those engineers. I don't know, I'm not in the university now, but when I studied, we had no subject related to sustainability or decarbonization. I finished in 2003, so that's a long time ago. But I don't know if that has changed, because I think that new engineers need to have this knowledge. When they finish the studies, I think that it is part, it is something that the market is going to demand them. So I think that we have to also work on that, on training for professionals, for young engineers, and to also, I mean, for the Colegio, just to develop those kind of trainings. I think it would be helpful.
Thank you. I have the last question, perhaps just for the both of you, Maria and Luis. We are living on a world of change, technological changes, regulatory changes. How do you see this standard to evolve over the time to continue to be really a right tool? Feature.
From a technical authoring team perspective, we tried really hard, hence we're on the table with everyone and his dog in the industry for 2 years, to make sure this standard is as future-proof as possible. And it really raises the bar for the carbon neutrality or net zero, however you want to call it, by 2050. We have made it generic enough to be flexible, to be ambitious, but specific enough with a guidance document for people to not be overwhelmed and just start out. I see PAS 2080 being there for a long time, and I'm hoping the sister PAS of resilience and other things will come into play, and hopefully for nature circularity. But I feel because it's not a technical standard, but it's a behavioral standard about decision-making and challenge, it hopefully will be there for quite a long time. That's how I'm hoping, yeah.
I agree. I totally agree. Don't get your hopes up that there's going to be a new PAS 2080 in the next few years. We're going to stick with this one. It's been future-proofed, as you say. I think you'd probably have a meltdown if you had to do it again. But no, it's future-proof. It's robust enough. And it's tempting. This is the problem, especially I think with consultants. I say this as a consultant, to say, oh, we could tweak that, or let's do another one. Let's do a reverse of that. We don't need to. PAS 2080 is enough. What we really need to do is just implement it. That's the trick.
Urgent call of action. Before going into 43 minutes is the time for us to leave the next section and the question and answers, the Q&A section. But before the Q&A section, can I ask each of the 5 last minute, 1 minute sentence, 1 minute conclusion? Leonardo,
yes.
You start?
Yeah.
Do you start?
Let's imagine that here there are, among people here and at home, there are 100 structural designers. And we have to design a bridge, normal bridge, structural concrete, which is like 500 meters long. If we save just 20% of the CO2 emission, we are able together to save 150,000 tons of CO2. That is equivalent to 150,000 flights from Madrid to New York. Our responsibility is huge.
Huge.
It's huge.
Marta.
I think I would like to advocate the role of maintenance and management that is not always very glamorous. It's always nicer to design things, like construct new things and do those type of activities. But we do have a role in reducing carbon footprint. So I would like to advocate that. And I would like to encourage asset managers to integrate this new vision, like resilient and sustainable vision, into their policies and their way of working.
César?
Just to finish, I'd say that we must be aware that it's our responsibility, but not our. It is my responsibility, it is your responsibility, and that I think that, and him, and his, and her, and all of us, because I think that the problem we have is that, okay, we all know that we have to reduce the carbon footprint of infrastructures, of buildings, and so on, but we always try to give this responsibility to someone else. I don't know, to the environmental department of my company. So it is a holistic approach, and we must be responsible for our own area, and we have to work on that.
Thanks, César. Maria, 1 minute.
I would say, yeah, a similar point, just communicate upwards in your organization. That needs leadership at all levels, and try and influence beyond your organization in any discussions you're having as engineers, because you're all respected people, so yeah.
Thanks, Maria. Luis,
don't be afraid. Don't be afraid of PAS 2080. It'll introduce another lens, as you say, another way of looking at things that will introduce efficiencies. It'll help things. It's low risk.
Low risk. Thank you very much. Thank you, all of you. Let's go into the Q&A section. That is going to be managed by Luis.
To talk from here, but that's fine. Well, thank you very much, everyone, and thank you for this exciting conversation. I think it's been very productive. In one of your slides, Luis, you were showing that, for me, the message was young people, they have a strong interest in carbon reduction, in sustainability, saving the planet, if we can say that. I definitely support that. In Darren Townsend, in my company, we can see in all the new cohorts joining our graduate program that the interest is huge, and they are very vocal in their interviews. I would like to be involved in this, so definitely they are the future, so I'm very optimistic there. And also, let me, just 1 second, I've got here my notes. And then the other thing I'm quite optimistic with is about how health and safety was implemented in the industry. If you remember, in the 60s, 70s, 80s, it was a bit of a mess. But then in the 90s, we started making a huge effort to implement this in how we think. It's a behavior thing. And the change is huge. I was discussing the other day with a colleague, if someone in the 80s jumps now in the present moment in the UK, one of my projects, for instance, and they see how the site compounds are established, all the health and safety equipment that we are using, how we are controlling everything, they will be in shock because there has been a huge change. So I think with this it's going to be the same. I'm so confident. It will come. We're demanding it. Then regulation will come, and it will be business as usual in 10 years, 15, I don't know how long, but...
Three.
Tomorrow. Okay, so in terms of questions, I'm going to ask if we have questions, but before, as I've got the microphone, I will make a question. Oh yeah, for you. I will make a question. We've been talking about collaboration, benchmarking, lots of things that really need us to work together, but at the same time, we need innovation. I think that's crucial. I think we have mentioned it a little bit, but to all of you, where do you see innovation here? How are we driving innovation in this process? Maria?
Yeah, I can make a start if you want. So, from my experience, if you have very stretching targets being set to you, by default, you will come up with amazing innovations, but as long as you don't have anything in your contract that prevents you or doesn't give you the time to think about those things.
Okay. Yeah. If you think, for example, to buildings. Now, if you go outside, we go in the street, we can see that everybody, all the buildings have the BREEAD, all this kind of certification that they are green. What happened with our structure, with our infrastructure? Basically, the buildings adapted a lot during the last 20 years. What happened with the infrastructure? We basically designed the infrastructure in the same way we designed 30 years ago. Probably the construction techniques are a little bit different, but the structural system is exactly the same. So of course there is a lot of room for innovation, not only from the material part, which is very key in this point, but also from the structural part. Take into account the maintenance. This is the key part of it.
Thank you very much. Now we're open to the floor. Okay, we have a question here.
As Maria said, we have very little time. That is something which is obvious. We had very little time 10 years ago, but now we have 10 years less than very little time. After having read the PAS 2080, I see it is a very philosophical document. I think we have to be more precise. I think to have to be more ambitious. It's my point of view. I agree with the philosophical, 100% with the philosophical approach, but I think we have to be more ambitious. I think we have to, I think PAS 2080 should divide buildings and infrastructure. Buildings is very homogeneous and should have limits. Regulation and limits. It's very homogeneous. Civil infrastructures are prototypes, so it is more difficult. But it has to go to regulation. Without regulation, this is going to be, the debate today will be the same more or less 10 years in 2030, because we don't have 10 years. Net zero is an engagement of our two countries and of many other countries, of developed countries, even the United States. We don't know what we'll do, but it's an engagement. So I think the PAS 2080 has to develop and has to make a step forward to methodology, to how to, of course it's very important, the approach from the design point, the design moment. It's very, very important. Do we need this infrastructure? Do we need this building? Can we renovate the building, or are we going to demolish and build a new building? It's a fundamental question, of course. But we have to go to methodology to quantify, because when I work in a building industry and I see so many, each consultant or each engineering firm gives a number, they're completely different. So one says it's 700 kilograms CO2 per square meter. The same building, others say 1,200 kilograms, same building, and not embedded, not operational. And in infrastructure, Leonardo said it's 80-85. In building industry, it is 60-40, or 65-35, or 50-50. So operational is very important, and even embedded, which is very clear, the differences are very, very big. So methodology, you have to go a step forward. Methodology, regulation, and more ambition. That's my view.
May I answer that? I totally agree. There's so many great points in there. I would point you towards the Australian guidance, right? Because that does, I think, what you're saying, and it builds on PAS 2080. I think it's sad to say that PAS 2080, PAS 2080 doesn't include any limits in it, doesn't include any kilograms per meter squared or anything deliberately, but even that it's hard to get that mandated. So the Australian thing builds on that. The other thing, and it provides a methodology and embodied carbon database, and it's like the next level, I think, which the UK should copy that now. But anyway, on the building side, the UK net zero building standard has just been released in the UK, and that redefines what a net zero building is, and it provides that sort of information that you're talking about, and it's got diminishing limits that match a trajectory towards net zero. And I think, I think as you're saying, we as an infrastructure community, civils community, which in many ways is more complicated than a building, we can look at that and think about how we should adapt that. But the cornerstone is PAS 2080, but I agree with all your points.
Thank you very much.
Can I just add something?
Yeah, of course.
So this is the billion-dollar question you're setting. We had the chat earlier before the speakers here. Who is the optimist, who is the pessimist? Now, I'm going to try and be optimistic here. So I agree with you. So the reason why we did PAS 2080 is because it was way before people were willing to listen even, to set standards with limits and numerical. This could take another 10, 15 years, yeah, especially for infrastructure. On your point about buildings being separate to infrastructure, the reason why we wanted to merge those two is because our buildings colleagues have the tendency to look at the world from their buildings view, one building, whereas, for example, if you took the whole of Madrid, say, and you needed to electrify some sort of heating that was not electric heating, what is better to start and what is cheaper to start retrofitting other means for the houses, or by electrifying all this heat, you would need to quadruple the electricity grid you have in the country, for example. That's why, from a systems perspective. Now, what you're saying, for me, the answer is each government have, yes, all these 2050 legally binding targets, but there have to be sectoral budgets introduced in transport, in water, in energy, in whatever, all economic infrastructure. And then, when there is a policy that comes out, and let's say the Ministry of Transport, Minister of Environment says, I need to build these things, only when you start comparing them to the budgets, you will be able as a country to say, can I actually afford to build these things with a carbon budget? And this is the most political and difficult decision to make. And that's why it's so important to start getting all these numbers and start the conversation with the policymakers. Ultimately, it comes down to that, but we cannot stand still, I think, until this happens.
I know, and that's another important point to make, actually. Think of this as a two-stage process. Stage one is to set the methodology for assessing carbon. Step two, which is a little bit further away, is setting the limits. Sweden has been excellent on stage one, and now they're at the point of trying to set limits, and that's where it gets political, as you say. That's where it gets very interesting. But that shouldn't put us off doing step one. Especially as engineers, we should know about these things.
Thank you very much. Do we have another question? If you can say your name and say where you work, you don't mind?
My name is Felix. Well, nice to meet you all, and very interesting. I'm Felix, and I work for McDonald's. My question to each of you would be, we are all civil engineers, we work a lot with civil engineers, there's plenty of us everywhere in work environment, but what would be your big takeaway, or what's your big lesson learned from working with other disciplines towards a low carbon future? Thanks. If any.
For example, as cement and concrete is not only in infrastructures but also in buildings, and buildings, I think they are more advanced than civil works, I think, in this sense. From my point of view, I have a lot of problems to talk to architects because I'm trying to monitor everything, I'm trying to measure everything, I'm trying to give values. And at the end, it is more, the approach, I think it is more, I would say, more qualitative and not so quantitative. So for me, I mean, from my experience, when working in the building sector, I think that we need to go forward in that quantification, in that measuring, or at least on talking about numbers, because I think the problem behind everything is numbers. I mean, to compare things, to set the limit. And in the building sector, with architects, I have realized that we talk different language in that sense. That's my experience, okay?
I was going to say that from my experience, and especially in transport infrastructure, we are like a sector of engineers, 150 to 100 years old. And when you talk to other engineers that are in more maybe innovative sectors, you find that they are less reluctant to change, and that we have to be humble. In our sector, we are a little bit reluctant to change. So I think that's something that we have to learn from other sectors of engineering.
We have time for one more question because I'm conscious of time. And do we have any question round? No?
I'll add one thing, which is the advice, which was not from me, but from a Chris Newsom, who was the former sort of head of carbon and clean water. So to succeed in this area, to move it all forward, you need 50% belief and 50% belligerence. You've got to believe it's the right thing to do, but also be prepared to fight for it. And we still, unfortunately, need to fight for it.
Thank you very much. Okay, well, round of applause for our panel, please. And thank you very much. And now I'm going to hand over to Luis Villarroya. Luis is member of the Colegio's board and International Commission president. So he will say some words for the session closure. Thank you very much.
Thank you. Mr. President of the Colegio de Ingenieros de Caminos of Spain, Mr. Deputy Director of the Institution of Civil Engineers of UK, keynote speakers, panelists, colleagues who today honor us with your presence, welcome and good evening. Let me start by thanking and congratulating to our keynote speakers and our panelists for these amazing and very inspirational ideas that you gave us today, and totally convinced that we will note, so that will be part of our ideas in the future. Today we have held a third summit that we have every year within the framework of the collaboration agreement between the ICE CICCP and the ICE, showing the great relations that exist between both institutions. This year, the topic has been innovation and sustainability for a low-carbon future, with a presentation and an interesting panel on the PAS 2028, an incredible methodology in my own experience and knowledge. I think that the moment could not be more appropriate. The importance of achieving decarbonization and stopping the evident climate change are magnified in times like the one that we have just experienced in the east of Spain, highlighting the urgency of stopping the destructive process in which we have introduced ourselves. From here, we express our sincere solidarity with all those affected and our commitment to support and serve to safeguard and improve the living conditions of our citizens. As consultants, engineers, and builders, we must contribute to the fundamental aspects of the climate agenda. This is climate adaptation, sustainable mobility, renewable energies, and circular economy. it is vital to recall that the global greenhouse emissions attributable to infrastructure, including transport, housing, buildings, and energy, is the 89%, I repeat, 89% of global emissions. If in 2023 the global emissions were 59 gigatons, that means that our industry has been responsible of 52. Terrible. The path to net zero could be based on government laws and regulations, but also in industry standards and initiatives. It seems that the most practical approach will be focused on individual projects, and that a full life approach to carbon emissions can help to reduce emissions in each stage. However, the real and sad situation is that infrastructure industry is not applying sustainable and life cycle impact in our projects. The myth that it's almost impossible to evaluate the carbon emissions in infrastructure projects is absolutely false. There are several methodologies based on national and international standards that help to carbon management in infrastructures. Some of them are the PAS 2028 that we have been talking about today, the ISO 14001, and the American Ambition. It doesn't matter which one we choose for our projects. The most important thing is to get used to using them and help avoid more dramas like the one we just experienced in Valencia. Today we heard that engineers are key players in the battle against the climate change. I fully believe it. You know, we have the most beautiful profession in the world. Why? Because with the science, we convert dreams into reality. Do our best to make through this dream of winning the climate change. And without further ado, I close this summit, thanking you all for your presence and trusting that you found it interesting. Thank you very much.